All right, we are going to start factoring, and there are a lot of different methods to factoring. We have the X method, we have the star method, we've got GCF, difference of squares, perfect square trinomial, and grouping, I think are all of them. So we're going to start with this. Part one is going to be factoring a equals 1, which is going to be using the X method. This is all based off of quadratics. So you've got your standard form. All right, your standard form of a quadratic is y equals ax squared plus bx plus c. A, b, and c are numbers. And then y stays there, x squared stays there, x stays there. It's a, b, and c that are the numbers. Okay, so basically for a equals 1, this part is always going to be either not there or say 1. So it's always going to be y equals x squared and then something going on. So what you would do is this is why we call it the X method, is you're going to put whatever C is here and whatever B is here. So then these would be numbers like 30 and 10 or something like that. Okay. It's going to be a little different when we get to A actually being a number, but right now when A is not a number, it's just 1, then that's why we just put C here and B here. So the things that would go here and here need to, let's give it, I'm trying to think what we could write here. We'll say M and N, okay? So M times N needs to equal C, and M plus N needs to equal B. So you need to find two numbers that multiply to be the top and add to be the bottom. So we're going to kind of just practice that first. So a good one would be 30 and 10, like I said earlier. What multiplies to be 30 and adds to be 10. So you can think of multiples of 30. So you've got 2 times 15, 3 times 10, not 4, 5 times 6. So these are different options. So if you were to add these together, you would get 17. If you were to add these together, you would get 13. Ooh, this is supposed to be 13. Sorry, guys. I just realized I messed that problem up. This is supposed to be 13. Okay. So add those up, you get 13, and then you add these two up, and you get 11. So what multiplies to be 30 and adds to be 13 would be the 3 and the 10. Okay, and then we have, one second. Okay, I have this page that has a bunch of different ones that are really, really good. So if you want practice, you can come back to this, pause the screen, and do a bunch of them. And these are just kind of practicing all different areas of them being like here and here, here and here, this side, up and down, so forth. Okay, so I'm going to do a few off of here. Let's see. Let's do 90 and 21. So that would be multiples of 90. So 45 times 2, 9 times 10, 3 times 30, 4 and 5. No. How many? 6. Is it 6 and 15? I think 6 and 15, right? Yeah. So I'm going to stop there because I found what I needed to find was 6 and 15 add to be 21. So 6 and 15 multiply to be 90 and add to be 21. So that would be my answer there. Okay, let's try one more. So this one's a negative one, negative 44 and 7. So let's just think of 44 for a second, like 4 and 11, 2 and 22, 4, 5, 6, 7, 8. I think that might be it. So one of them has to be negative, but we also need a positive 7 there. So you could do the 4 and 11, and you could make the 4 negative. So positive 11 and a negative 4. So 11 times negative 4 gives you the negative 44, and 11 minus 4 is 7. So that works perfectly. Okay, so back to the factoring. Again, if you want to practice, you can pause this and practice these problems. So the factoring part, if you have a problem like this, we need to set it up like this. So the C, that's our last number. And we know that it's an X method because there's nothing in front of here. So we would take our X, we would put the C value, which is 4, on top. Our B value is that middle one that goes on the bottom. So that's 5. So what multiplies to be 4 and adds to be 5? Well, there's not that many choices because you only have 2 times 2 and then 4 times 1. So this one's going to be 4 times 1. That equals 4 when you multiply, and then you add those together, that equals 5. So to get the factored form, because we're not done yet until we factor it, you would take these two numbers and you would put an X in front of them, basically with parentheses. So this would be X and then plus 4 is our first answer. And then for the 1 would be X plus 1. So that is the factored form of this quadratic. And you can go back and forth. You can multiply these together and you should get this answer. That's how you know you did it right. So that would be a check method. All right, one more. Let's do, okay, so we set up our X first. So again, our C value goes on the top, so 10, and our B value goes on the bottom, negative 7. So what multiplies to be 10 and adds to be negative 7? So you only, again, have two choices, 10 times 1, which isn't going to work, and 5 times 2. So if we use 5 times 2, we need this to be negative, but we need that to be positive. So if you make both of them negative, a negative times a negative is a positive. So that works there. And then negatives add together to be negative 7. So that works perfectly. So to get our final answer, we take X and we put it in front of both of these numbers in parentheses. So the first one would be X and then minus 5. Our second one would be X and then minus 2. And that is your answer. That is factored form of this quadratic.